Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on 10F assignment. First one we're taking a look at here is number 1. Each of these spinners is spun once. Find the probability of spinning a green spinner on 1, which would be 1 out of 4, and a blue with spinner 2, which is 1 out of 6. Since it's and, that means we're going to multiply, so that should be 1 out of 24 chance. Okay, next one to take a look at here is number 3, school bus. School has 2 photocopiers. On any given day, machine A has an 8% chance of malfunctioning and machine B has a 12% chance of malfunctioning. Determine the probability that on any given day, both machines will malfunction. So if we're looking for the chance of the first machine to malfunction, that is 8%. So we'll do that as 0.08. And let's see, given machines that they will both, so that means it's machine A and, which means multiply, machine B, which is 0.12. So we will simply multiply those together and see what we get. Okay, so we do 0.08 times 0.12, and that gives us 0.0096, which means well, that's the probability that will work officially, but just so you kind of get an idea, that's 0.96%, so less than 1% of the time that will happen, unless you're here at my school where it happens way more than that, I feel like. Anyway, moving on to number 4. A couple has 4 children, none of whom were adopted. Assuming boys and girls were born with equal likelihood, find the probability that the children were born in the order boy, girl, boy, girl. So probability that it was the first one is a boy, 1/2. Probability that the second one is a girl, 1/2. Probability of the third one being a boy, 1/2. Probability of the third being a girl, 1/2. So if it's going to be exactly in that order, it's going to be boy and then girl and then boy and then girl. So all multiplied together, which gives us 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1 out of 16 would work just fine. And you can also turn that into a decimal if you want. 1 divided by 16, which gives us 0.0625, which is 6.25%. Okay? Okay. Moving on to number 5. 2 marksmen fire at a target simultaneously. Yuri hits the target 70% of the time. Benita hits it 80% of the time. Determine the probability that A, they both hit the target. So if Yuri hits it 70% of the time, that's 0.7. And, which means multiply, Benita has to hit it too, 0.8% of the time. That's going to be 8 times 7 is 56, right? So 0.56, which is 56% of the time. Okay? B, probability that Yuri hits but Benita misses. So Yuri hits it at 70% of the time, 0.7. And then Benita misses, so if she hits it 80% of the time, that means the other 20% of the time, 0.2, they will miss. So that 0.7 times 0.2 is 0.14, or 14% of the time that will happen. Okay? Taking a look at the next one here, number 7. For a particular household, there's a 90% chance at the end of the week the rubbish bin is full, and a 50% chance that the recycling bin is full, independently of one another. Draw a tree diagram to illustrate this situation. So we could do this. Oops. That's better. Here we go. So we could say this first thing here is going to be the rubbish bin is full. So this will be the probability of the rubbish bin. And so we'll say rubbish bin being full or not full. So the probability that it's full is 0.9, because that's 90%, right? So not full is 0.1. In fact, we should probably, to make this a little bit more consistent with what we've been doing, let's do this. So this will be full, and this will be not full. Okay, and then 50% that the recycling bin is full. So then from here, we'll do, so this is rubbish, and this is recycling. So this would be full, and this would be not full. And these are independent of each other. Either way, it's 50%, so it's 0.5 here and 0.5 there. And then we've got full and not full. Again, also 50% for both of those. So there would be our tree diagram. Using our tree diagram, find the probability that at the end of the week, both bins are full. So we would simply just go full, full. That's this branch here, which is 0.9 times 0.5 because it's full and full. So they have to, and means again multiply. So that's 0.45. So 45% of the time, they're going to both be full. Okay? Moving on to number 8. 2 baskets each contain 5 red apples and 2 green apples. Celia chooses an apple at random from each basket. Draw a tree diagram to illustrate the possible outcomes. So let's say basket 1. We can either get a red apple or a green apple. The red apple, there are 5 out of 7 total apples. And where green, there are 2 green out of the total 7 apples there. And then, let's see, 2 baskets are identical. So then we're going to do the same thing for basket 2 to get a red or a green. And then same thing here, red or green. It's a completely different basket. So this has no impact on what happens here. So we've got 5 out of 7 red apples. 2 out of 7 of them are green apples. Same thing down here. 5 out of 7, 2 out of 7. Okay, so we have drawn our tree diagram to illustrate the possible outcomes. Find the probability that Celia chooses 2 red apples. So that's going to be red apple, red apple. That's this branch here. 5/7, and the other one happens as well. 5/7 times 5/7 is 25 over 49, which is just fine to leave it as a fraction. You can also turn it into a decimal if you want. That looks like that's just over 50%. And then, so that's this one here, and the probability that 1 is red and 1 is green. So that can be, just to show this in a different color here, so that could be this path here, red and green here, right? Or it can also be this path here, which is green and then red. So that would be 5/7 times 2/7. And this is going to be 2/7 times 5/7. And it can be either one of these, either or. So we're going to find this probability, and then we are going to add them together to get the total probability. So 5 times 2 is 10. 7 times 7 is 49. This is also 10 out of 49. So we are going to add these two together. 10 out of 49 over 10 out of 49. Adding those together gives us 20 over 49 probability that you will get 1 red and 1 green, since the order does not matter what you get that in. Okay? All right, taking a look at number 10. Anya rolls an 8-sided die twice. Find the probability that exactly 1 4 is rolled. Okay? Okay, I like to use these little 10 by 10 grids that I've got plenty of. So if you have run out or you need some, just let me know and I'll get those to you. But if she's going to roll 8-sided die twice, find the probability exactly 1 4 is rolled. So first off, we're just looking at this 8-sided group right here. So I'm going to box off what we want. We want to go from here to here. So just what's up in there. So this out here is extra. We don't need that. It doesn't help out our problem that we're looking at. So what's the probability if she rolls an 8-sided die twice? Find the probability that exactly 1 4 is rolled. So we can look at this as there's 8 times 8, there's 64. Oops, wrong color there. There's 64 possible outcomes, right? So here's a bunch of 4s here. That would be, say, the 4 on the first die, and there's 4 on the second die, right? So these are all our possibilities. Exactly 1 4 is rolled. That means it would not include this, but it's going to include all the rest of these. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That would be 14 out of the 64, which would be what? 7 out of 32. Probability that exactly 1 4 is rolled. Okay, so we're going to do this. B says at least 1 4 is rolled. So really, we don't need a whole different one for that. So this is where at least 1 4, at least 1 4. That's going to actually include this middle one. So that's going to be 1 more. So that would be 15 out of 64. Okay? Okay. All right, last one to take a look at, 13. Kane plays 3 matches in a darts challenge, alternating between Penny and Quentin as his opponents. Kane must win 2 matches in a row to win the challenge. Kane's allowed to choose whether he plays against Penny, then Quentin, then Penny, or against Quentin, then Penny, then Quentin. He knows that Penny is the better darts player. Which strategy should Kane use to maximize his chances of winning the challenge? Justify your answer. So really, one way to look at this is, so if Kane plays 3 matches total, he's got to win 2. That means if you've got to win 2, you got to for sure must win the middle match. Oops. Win second match, right? Because if he wins the first and the last, that doesn't count because he's got to win 2 matches in a row. So if you must win the second match, it would probably be wisest to play the weakest opponent for the second match, which would be Penny is better. So we'd want to do Penny, Quentin, Penny. So Penny, Quentin, Penny, because he's got the best chance of beating Quentin there. And then just has to win one of those 2 against Penny, either the first or the second one versus Penny. Okay? So Penny, Quentin, Penny, because got to win the second match. That's important. Okay? All right. That's all we have for problems on the 10F assignment. If you have any further questions on any of this, please feel free to ask. Thanks.